First, let's review solid angle. It's a concept that not everyone uses, and we're going to need to be able to calculate it easily. So here's a sphere. We have a certain radius of that sphere. There's a cone, and the cone has a certain patch of area on the surface of the sphere and has a central half angle of theta. So the radian is defined as theta, as the arc that would describe the radius of this little circle here, of area A, over the radius of the sphere. And of course, you know that the circumference of an arc related to the radius, there would be a total of 2 pi possible radians. The total distance around the circle would be 2 pi times r divided by r. Solid angle is the obvious analogy now to 2 dimensions, is we take the area of our spherical cap and we divide by r squared. And if you remember the area of a sphere, 4 pi r squared, that tells you that a total sphere, the biggest solid angle you can have, and we do have light sources that do this, would radiate into a solid angle of 4 pi steradians. By the way, the word stare there comes from stereo, which from the Greek means solid. So that's why it's solid angle. It's just the translation. So let's do a little bit of calculation just so we have the tools we need. By definition, solid angle is the area over the radius of the sphere squared. Well, we can do just our standard trig here to know what the area of that little cone is, integrated in 2 angular coordinates from the spherical coordinate system. We can do that integral, and we find overall that the area, the solid angle, of the patch is 4 pi, well, that makes sense, there's our maximum value, times the sine squared of the half angle over 2, and that's just from this little trig identity here. So that's a convenient equation to have that tells you how to get between angle in radians and solid angle in steradians for an arbitrary angle theta. It's convenient to expand this in its lowest order for small angles. And so for small angles, where we can take the first order approximation to the sine, there's simply a quadratic relationship between the angle in radians and the solid angle in steradians. So we'll need that math because we're going to be calculating steradians a fair amount as we go through the rest of this module.